Hello all. Today we are going to see our next characteristics of cubic crystals, and this is nothing but atomic radius. If I ask you to define atomic radius, then you might define it as radius of an atom. It's also correct, but when we deal with the crystallography chapter, then one should express the atomic radius of the material or the element in terms of its lattice parameter or a primitive or a edge, and hence the definition of atomic radius as per the crystallography is it is a half the distance between nearest neighboring atoms in a crystal of a pure element. It means that if two atoms are situated very close to each other, then it is the distance between the nearest neighboring atoms. That is the half the distance between neighboring atoms. As shown in diagram second, you will get idea about it from diagram second, because I have shown with the dotted circles two atoms which are closely associated, and it shows at the center a cube is formed. We know that as this is a cubic system, its all sides will have length as a. Therefore, if I want to calculate the radius of one atom, then it will come out as a by 2. huh? And this is the radius of a simple cube. Then next, atomic radius of a BCC, that is body centered cube. This is the first diagram denotes the picture of body centered cube. It consists of 8 corner atoms and the atom situated at the center of body. It means that its radius is twice r, and the contribution due to these half atoms are r. Therefore, the diagonal of unit cell come out as 4r, and in second picture you will get idea that when we consider a body centered cube, then its three edges come into picture, that is a and a. Now don't consider here triangle acg, as the notation in a picture are different from that I have taken. Therefore, during our lectures, I will repeat this session again on a board so that you will get idea about triangle ACG that I have considered. For example, consider this only figure, and from this figure we will come to know that in this second figure, diagonal square, that is 4r is the diagonal, and diagonal square 4r bracket square is equal to a square in plus a square, means 3 into h square. Therefore, diagonal square is 16r square is equal to 3 into a square. Therefore, r square is equal to 3 upon 16 into a square. Hence, the value of radius of BCC comes out as root 3 upon a, root 3 by 4 into a, root 3 by 4 into a, root 3 by 4 into a. Here is one typing mistake, root 3 upon 4 into a. Or root 3a by 4. It's correct. The next is atomic radius of FCC. Have you understood? We will repeat it again. First, we will move towards FCC. In FCC, there are 8 corner atoms. Along with that, 6 face centered atoms. If we consider one of the face, then its picture will look like in as shown in second figure. It means that here also diagonal will remain same as 4r, but there are only two edges are in picture and its length are a and a. Therefore diagonal square is equal to a square plus a square, that is 2 into h square, h square. Therefore 4r bracket square is equal to a square plus a square. 16r square is equal to 2 into a square. Hence r square is equal to 2 upon 16 into a square. Hence r is equal to root 2 upon 4 into a. It is the value of atomic radius of FCC. You have to remember all these formula as there are going to be examples based on atomic radius of the cube or FCC. Hence, we will repeat the session once again. The atomic radius is nothing but half the distance between nearest neighboring atoms in a crystal of a pure element. For SC, its value is a by 2. For BCC, its value is calculated by using the formula diagonal square is equal to 3 into h square. As it is a cube, its all sides will remain same, that is a. Hence 16r square will equal to 3 into a square. It will give us value r is equal to root 3 upon 4 into a. Similarly, one can find the value of radius of FCC and it comes out as r is equal to root 2 by 4 into a. Thank you.